Okay, the next type of equation that we'll focus on in this section is the quadratic. Okay, and there are a few more strategies here that we have to focus on, and we'll take a look at 3 problems in this section. So first of all, our strategies are to use a temporary substitution to make our equation look simpler, meaning x is equal to something, some trig function. Okay, if there are common terms or a quadratic, then we're going to have to factor, which is why we practiced factoring. We'll use the zero product property to solve for the trig function, and then find the angle in radian mode within the domain restriction stated. Typically, it's going to be from 0 to 2 pi, typically. There are the possibilities that we could have what's called an extraneous solution. Okay, and this is where you're going to get an answer, but it doesn't work. Okay, so let's start with something simple here. We could do this a couple different ways, but what we're going to do is use what's called a let statement. And we're going to say let sine theta, because that's this trig function here, be equal to x. So what I'm going to do is I am going to plug in for the sine of theta and x. So now what I have is x squared minus 1 is equal to 0. This is something we should recognize from algebra. This is a difference of squares. X minus 1 times x plus 1 is equal to 0. Okay, so now I'm going to set each factor equal to 0 and solve for the values of x. So x is equal to 1 and x is equal to negative 1. I then need to make my substitution back in here because this is not my original equation. So I'm saying that the sine of theta is equal to positive 1 and the sine of theta is equal to negative 1. So again, on the unit circle from 0 to 2 pi, I need to say, okay, what angle can I put in here and get an answer of 1? So in this case, theta is equal to pi over 2. What angle can I plug in for theta and get negative 1? 3 pi over 2. Those are my 2 answers. Okay? Now, something I need to caution you on. You need to make sure that when you are factoring, you don't forget to go back and put your trig function in here. Okay? Okay. Now, let's take a look at this one. Remember, folks, whenever you are solving, you must set your equations equal to 0. So the first thing that we need to do is set this equal to 0, and then we'll make our substitution. 2 cosine squared theta minus cosine theta is equal to 0. Our let statement is the cosine of theta will be equal to x. So I'll use a different color here. Okay? So we're going to make our substitution right here and right here. So we'll say 2x squared minus x is equal to 0. We have to factor. Factor out a greatest common factor. So in this case, we take out an x, leaving us with 2x minus 1 is equal to 0. Set each factor equal to 0. X is equal to 0. 2x minus 1 is equal to 0. Here, we can make our substitution, but let's solve here first. Add 1, divide by 2. Okay, so now what we want to do is make our substitution here and plug the cosine of theta back in. Cosine theta is equal to 0. So you need to ask yourself, on the unit circle from 0 to 2 pi, what angle or angles can I plug in here and get 0? In this case, it's going to be pi over 2 and 3 pi over 2. Okay, there's 1. Then I need to look at this one. Cosine theta is equal to 1/2. I actually have 2 answers here. Where is cosine theta equal to 1/2? Pi over 3 and 5 pi over 3. So you have a total of 4 answers. In this last problem that I chose, I wanted to show you that you can actually factor, and we did practice factoring. Not all of us were proficient, but we'll get better at it. Automatically, this is set equal to 0, so I'm going to make my substitution. We're going to say let cotangent theta be equal to x. So let's choose yet another color. Let's say this. So I'm going to make the substitution here and rewrite this equation. X squared minus 2x plus 1 is equal to 0. We have to factor that. So in this case, we're left with x minus 1 times x minus 1 is equal to 0. This factor is exactly the same, so that means the 0 is exactly the same. So it doesn't matter if you set both factors are 1 equal to 0, you're going to get the same answer. So we're saying that x is equal to 1. We then need to make our substitution and say, okay, what angle would I plug in here where the cotangent is 1? If you can't remember this, what do you know better? Tangent. So flip both sides over. Tangent theta is equal to, the reciprocal of 1 is 1. So we're saying that theta is pi over 4 and 5 pi over 4. This is in third quadrant.